One might ask, what's the negative of a vector? Graphically, it's like you see them here. I have two vectors, 1 and 2. They have the same magnitude, as I hope you can see, but then they have opposite directions. These two vectors are negative of each other. Okay, if I use the pen, if I call this vector A, and I call this vector B, B is actually equal to minus A. As simple as that. Now, mathematically, if you look at them, what makes them equal? The magnitude is the same. Magnitude, remember, we represent it by putting the vector between two bars like this. So the magnitude of B is the same as the magnitude of A. Remember, the magnitude tells us the amount, how big something is, so it cannot be negative, it's just positive. So they have the same magnitude. The directions are opposite to each other. So mathematically, how do we represent that? So if the direction of A, let's call it theta sub A, and if the direction of B is theta sub B, so theta sub B is equal to theta sub A plus 180 degrees. That's the direction of the negative of the vector A. So we just have to add 180 degrees. Let's again go to the simulation and look at our vectors and decide which ones are negative of each other. So they have to have the same magnitude, like these two, and they have to have opposite directions, like these two. Oops. So let me get it to show them again. Okay, because if I act on the tip, I change both the magnitude and the direction of the vector. So they are equal in magnitude and opposite in direction. One thing we can check is look at the angles. The angle for the gray vector is 158.20. If we add 180 degrees to that, we should get this one here, which is 338.20. Okay, just if you want to verify that, okay, 158.2 plus 180. That's what you get, 338.2, like what we have here. Okay. Now, what if we multiply a vector by a scalar? The new vector, okay, so again here, our vector is vector A. It's represented by the blue arrow here. If I multiply it by a scalar C that's positive, then the new vector is just C times A. The magnitude of the new vector, let's call it B. The magnitude of B is just C times the magnitude of A. Now, C can be smaller than 1 or larger than 1. So the new vector can be smaller than A or larger than A. Now, what if our scalar is negative? I represented it here by minus C. So our vector D, its magnitude is going to be the absolute value of C times the magnitude of A. Now, what about the direction? If C is positive, theta sub B is the same as theta sub A. Now, if C is negative, theta sub D is essentially using the same concept that we have learned when we worked with the negative vectors. When we multiplied it by a negative scalar, we get a vector pointing in the opposite direction. So the new direction is going to be theta sub A plus 180 degrees.